Okay, great. We're recording now. Perfect. Hello, everyone. Welcome to the Q&A session with Professor David Deutsch, hosted by the Oxford Quantum Information Society. We are a student group at Oxford organizing events about quantum information sciences and quantum computing. Actually, the first such group founded a few years ago. Today we have from the society, Nisatu, Simone, Amin, Jan, and Benji joining us. I think Maria is also here. She was the president 2 years ago or 3 years ago, and one of the founders of the society. I'm Mert. I'm a physics DPhil student at Oxford and the president of the society. I must mention that this session is personally important for me. During my freshman year at Stanford, I was taking a philosophy of physics class, and I was exposed to a quote by Professor Deutsch, where quantum computers were given as an argument to the multiverse. I learned that factorizing large prime numbers efficiently could be done on quantum computers, as shown by Peter Shor. And to quote Professor Deutsch,
it's large composite numbers.
Yes, yes. Thanks. So to quote Professor Deutsch from The Fabric of Reality, so if the visible universe were the extent of physical reality would not even remotely contain the resources required to factorize such a large number. Who did factorize it then? How and where was the computation performed? After this non-intuitive and novel description, I got extremely interested in quantum computing, or at least that's what it seemed non-intuitive at the time. And now 6 years later, I'm doing a PhD on it. We're extremely lucky to have Professor Deutsch joining us today. It would not be an exaggeration to say that Professor Deutsch is one of the pioneers of quantum computing. He defined universal quantum computing and discovered the first formal algorithm that showed quantum computers can be more efficient than classical ones, demonstrating what we now refer to as quantum advantage. And Professor Deutsch is currently a visiting professor here at Oxford. Today we'll have the chance to ask him some questions. We prepared some questions, including the ones you sent us while signing up. But you can, in fact, you're encouraged to ask questions as we go along. Just use the hand raise feature on Zoom when you have something to ask. And if we don't see you for some reason, please feel free to shout out. We want this to be a free, open for all this discussion. Actually, we're aiming for this to be as interactive as possible, so it would be nice if you could turn on your cameras. FYI, the meeting is being recorded, so if we might do some edits before publishing. If you have some problems, just email us, message us. And the questions we prepared mostly revolve around Professor Deutsch's book, The Fabric of Reality. We divided the questions into the 4 strands of reality discussed in the book. Computation, quantum physics, evolution, and I don't know if you can see what, epistemology. Okay, I guess we can get started with computation. And Professor Deutsch asked me to address him as David, so I'm going to do that. David, you proved universal quantum computing under quantum physics, extending on Alan Turing's universal computing principle. And now quantum computers are being built today. What do they tell us about the multiverse interpretation of quantum physics?
I think the computers that are being built are, from the point of view of telling us about the multiverse interpretation, they are just a matter of psychological impact. The real implication for the multiverse was already there when people first described single particle, single photon interference. And then especially when people analyzed entanglement in those terms. And then especially when the theory of the universal quantum computer came along, And then there was also my thought experiment, which involved a artificial general intelligence running on a quantum computer, and performing an experiment to actually test the many universes interpretation, or Everettian quantum mechanics, as I prefer to call it. So, and those were all theory. So, well, I suppose the single photon interference wasn't just theory, but everything else was pure theory. And when we have a working universal quantum computer, as a matter of logic, the case for Everettian quantum theory was already made and was already unanswerable before, but it is just that much more cognitive dissonance for people to cope with if they insist on denying it.
Okay, I'm gonna go on with our questions if no one is raising their hands, and feel free to shout out again if that's fine with you. We actually had a lot of questions come up about your inspiration for the Deutsch algorithm and the Deutsch-Jose algorithm. Can you briefly talk about the algorithm itself and maybe your inspiration for it?
Yes, well, the first algorithm that I proposed in my first paper on universal quantum computer was in fact not the one that's called the Deutsch algorithm today. It was much had much less power. So I've really usurped somebody else invented a thing called the Deutsch algorithm, or probably several people simultaneously. But then the Deutsch-Jose algorithm was invented basically by Jose. He came to see me and said he wants to talk about quantum algorithms, and he showed me how you could execute something that in the end turned out to be what's called the Deutsch-Jose algorithm. And when he was halfway through his explanation, I said, wait a minute, that violates the theorem that I proved in my first paper, that quantum parallelism can't increase the average speed of computing anything, but can only increase the speed, the fastest speed. And so he just casually said, oh yeah, that was wrong. So, oh, my theorem was wrong, right? Good. And the reason it was wrong is that I had what I called quantum parallelism in that first paper was a particular form of quantum parallelism, which was the first one I thought of, and which I described in that paper. But in fact, there are many other forms, and they are more powerful, and in fact, exponentially more powerful. So we ended up writing the paper about that, and that was the Deutsch-Jose algorithm. One way it is conceptually an improvement on my original algorithms was that it involved directly manipulating the phase. And manipulating the phase is obviously a more direct way of getting to interference, which is the basis of the power of such algorithms. Some people say it's entanglement, but it's the same thing really, because you adjust a phase somewhere and you also adjust it somewhere else in the Schrodinger picture. Very misleading, but there you are. That's the Schrodinger picture for you.
And you mentioned entanglement, and we had a question about that as well. How is entanglement phenomena explained without any signal passing between two entangled pair of particles?
But it does pass. The thing is, in order to test entanglement or to demonstrate any entanglement phenomenon, you need to do experiments on one locality, depending on the results of experiments in another locality. And how did the information get from, and you could, so how did the information get from one to the other? Well, the answer is, it gets there in the, inside the classical qubits that one sends from one side to the other to determine what experiment to do. That shows that perfectly classical bits, or bits which to all local experiments look perfectly classical, actually contain quantum information inside them, which is stable to decoherence. Because it's stable to decoherence, you can't measure it, but you can use it to convey the quantum information from one system to another, and then, and only then, can you detect the entanglement phenomenon.
And I'm assuming that's a classical signal, obeying the limits of speed of light.
Yes, although the calling it a classical signal kind of begs the question, or makes the explanation more obscure than it needs to be. The term classical signal or classical information is ambiguous. It can either mean a signal expressed in classical bits, each of which can be 0 or 1, and that is not a physical thing. There is no such thing in nature. Or it can mean a quantum system, which all systems in reality are, in which the information is decoherent. But it can be shown, and Hayden and I showed in a paper that that such, quote, classical systems can contain hidden quantum information.
And by Hayden, I assume you meant Patrick Hayden?
Yes.
I guess we moved into the realm of. Oh, yes.
I might have a very naive follow-up on that. So when you talk about the classical bits having some hidden quantum information, does that have anything to do with the famous hidden variables theory, or?
No, it's the opposite, really. We called it locally inaccessible information. That is, it's information that cannot be accessed by a local measurement on the bit that travels from A to B. But it can be accessed by doing an experiment that involves both A and B, one after the other. So the information is there. It just can't be accessed by an experiment purely on the traveling bit.
Great, thanks for the question, Vansh. I guess we moved into the realm of quantum physics, and I mean, I guess you were arguing that the 4 strands are linked, so that is natural. Could you give an overview of the experiments that provide the best evidence for parallel universes? In other words, what should an experimentalist know about many worlds? This actually came from an experimentalist in the department, so.
Right, well, it depends. So any experiment that provides evidence, one of the other strands, namely the epistemology strand, tells us that evidence is meaningless unless there are at least 2 theories predicting different things about the evidence. Otherwise, one can always reinterpret. If one only has one explanatory theory, one can always reinterpret any result as conforming to that theory, if only by saying it was an experimental error or a fraud or something we don't yet understand or whatever. Which experiment is most convincing depends on which rival theory you have in mind as being the one you would jump to if the Everettian quantum theory predictions were refuted. So the basic experiment is, as I said before, is just any interference experiment, and the more complex the variable that's involved in the interference, the more convincing the experiment is. So that's why people did experiments with interfering neutrons, and then with interfering molecules and interfering buckyballs, and they keep trying to make viruses interfere and so on. And eventually we'll have, as in my thought experiment, we will have interfering AGI programs. And that will rule out, then one can actually perform the Wigner's friend paradox in real life and show that Wigner was wrong, and that what actually happens is that the AGI can recall evidence of itself having had more than one experience simultaneously. That I think would, if it could be done eventually, would be the ultimate answer. But really, it is, as I keep saying, and I hope nobody's offended by this, but I think it has been incoherent to deny, to insist that there is only one universe ever since 1957, when Everett wrote his paper describing his so-called interpretation. It's not an interpretation, it's a theory. And the theory that it is quantum theory. Oh, I should say, so as I said, it depends on what alternative theory you have in mind. If you have in mind the Bohm interpretation, that is an interesting case, because as I've often said, the Bohm or the de Broglie-Bohm interpretation, or the pilot wave interpretation, is the many worlds interpretation in a state of chronic denial, because the wave function in that theory has got unoccupied grooves where the representative particle doesn't travel, and yet those grooves affect the particle. So some of those grooves are human-shaped grooves in which there are thought-shaped events, and those thoughts affect other thoughts. And so it's really just a matter of terminology to deny that those thoughts are the thoughts of real people. If we could do such an experiment explicitly, we would have exactly as much evidence of the people in the other universes as we have of people in our universe. In both cases, that is more evidence than we have of the existence of dinosaurs in the past. In both cases, we cannot experience them directly, but we can experience evidence that is inexplicable without postulating that they exist.
I see. I guess matching Bohmian mechanics builds up to our next question. Oh, we have a question from Mo.
Yeah, hello. It's an honor to speak here. I was wondering, so I read about the moral implications of the many worlds theorem. I was just wondering if you had any thoughts on that.
Yes, I think the only moral implication of it that's different from what morality was before one knew about it is that one ought to advocate it. That it is morally wrong to insist that it's false.
Sorry, I meant more that so do we have to start worrying about all these other possibilities?
Yes, no. So I'm saying that we don't have to worry about those, because it's interesting. I'm often asked that question, but in two different forms. One form is saying, well, since you know that every time you drive out in your car, you will necessarily run someone over in some universe, so shouldn't you be more reluctant to drive a car? And the other is, well, whenever you run someone over, they always survive in some universe, so maybe you should be a bit less, worry a bit less. So I think the quantum theory of probability and decisions, which comes out of the Everettian quantum theory, tells us that precisely that, well, at least when we're doing decoherent things, so it wouldn't necessarily hold during my thought experiment, but when we're doing decoherent things, we should attend to probabilities exactly as if the outcomes were determined by probability with the Born rule.
Mm-hmm.
So it should not make us more reluctant or less reluctant to drive a car. What happens when we are fully uploaded into quantum computers and then are thinking we're thinking coherent, quantum coherent thoughts? No one knows yet, I think. Certainly I don't.
Certainly going to be an interesting future. Thank you.
We have a question from Babak.
Yes, thank you. And hi, David.
Hi.
I was wondering how you would explain the quantum Zeno effect, or paradox, however you want to call it, within the Everettian quantum theory, which, yeah.
Yes, so do you mean the actual Zeno effect, or do you mean the Elizur-Weidmann-Bohm phenomenon?
Oh, no, so I mean the effect being, or the watched pot effect.
Yeah.
Mm-hmm.
Well, that's a case where one is it's another experiment that confirms the Everettian quantum theory. What one is doing is one makes a measurement which is overwhelmingly likely to have the answer A and has a very low probability of having the answer B. Then one does it again, and so on. And classically, the probability of getting a B would go up, actually quantum mechanically as well. But you can arrange, but because quantum probabilities add up in a different way from classical ones, you can arrange so that in the limit, B will never happen. Will happen with an arbitrarily small probability. So that is simply again, I think that's better understood in the in Everettian quantum theory, because you are simply putting yourself in a larger and larger fraction of the universes.
Thank you.
Right, thanks. Faye?
Hi, Professor. I'm doing quantum thermodynamics, and someday I explain the multiverse and quantum computation speed up to my friends who are doing arts, and they take a very different viewpoint of it, and they ask a question that concerns it a lot. They said that, would it be that we steal resources from other universes to speed up the algorithm we have at this universe? So this concerns me. Is it a collaboration between universes to make the computation faster, or just a computation between different universes? This perhaps correlates with your conservation laws between universe. I noticed that there is a conservation of knowledge in your book. I thought, could these two questions related, but I'm not sure. Thank you.
Yeah, well, so I think this conservation of knowledge and that kind of thing happens where there's not only quantum theory, but closed time-like lines as well. So just setting that aside for the moment, quantum computation never involves stealing anything from other universes. It's always a collaboration, but not only a collaboration, it's a collaboration between different versions of the same people that started the computation. So somebody programs the computation, and that programming happens in a certain range of universes. Then, as the quantum computation proceeds, that range of universes, which were initially identical, with everybody putting in the same program and wanting the same answer, wanting the same number factorized or whatever. And then, as the computation goes on, this range of identical universes differentiates itself into a vast, vast number of different universes, all performing a different computation. And then they are recombined, but not all with the same phase. So in such a way that they all, well, in some, for some algorithms, it's not all, it's just most, but let's say in a simple case, they all end up with the answer. So there's no stealing going on. They have entirely, but not only are they collaborating, but they're collaborating on the same problem.
I see, thank you.
Thanks. Ante has a question.
Hi. Recently in your conversation with Robin Hanson, you said that the problem of a Y risk and frequencies can be approximated by probabilities is an unsolved problem.
Yeah.
And I was just wondering how come the quantum theory doesn't solve that problem, or why isn't it that probabilities are just frequencies in the multiverse?
Yeah, very important question. It's because when you're betting on roulette or something like that, which we can be approximated as a quantum process, what you mean by using probabilities is that you'll get a different answer in different universes. But when you bet on, let's say, one company over another, you're not betting that the company that like, suppose you have you can bet on two companies and you're wondering which one of them is going to make more profit than the other or give a higher dividend than the other or whatever. It's not that you're expecting the universes to divide equally, supposing its risk is 50-50. You're not. You're saying that you don't know how they're going to divide. In fact, you might be fully of the opinion that the universes aren't going to divide very much with respect to which company is better. That one of them is unequivocally better, but you do not know which it is. And that ignorance is somehow translatable into a probability, but that violates the theory of probability. The deriving knowledge, including knowledge of probabilities, from ignorance is a cardinal mistake in probability theory. So it's not that. It must be that there is some way of dealing with knowledge which gets you to say a rational decision. And then you can work backwards and say, well, because that's the rational decision, the implicit probability must have been so-and-so. By the way, there are other cases where using probability and using classical decision theory at all is a mistake. So this equivalence between decision-making in the decision-making under real ignorance and decision-making under probability doesn't hold. And really the only thing you can say is, I don't know. And you have to resort to other objectives, such as minimizing your maximum loss or maximizing your minimum gain or whatever, or just to keep out of it if you can. So I don't know, as I say, it's an unsolved problem. Did I understand your question correctly? I mean, you said, why isn't it the same? Well, for probability to make sense according to quantum theory, it must be because things are distributed in a certain way in the multiverse. It cannot possibly work when it isn't distributed much in the multiverse, but you just don't know.
Yes, I think you understood it correctly.
Okay, well, tell me if you have the answer.
Okay. We have another question, if there's no follow-up on that, from Jan, who's part of our society.
Hey, David, thanks so much for...
Oh, yeah, you're in the room, I guess. Yeah. Okay. Yeah, so we have a viewing party. I'm not in the same room so that we don't have the echo. Yeah, okay, here we go.
I'll ask you. Thanks so much for taking time. So on the topic of Bohmian mechanics, I was just introduced. So if you look at like modern versions of Bohmian mechanics, there's usually for Bohmians, there's these two important different frameworks. There's a configuration space in which the wave function evolves, and there's also a physical space of particles in which particles evolve. And then there's, for example, interpretations where one says that the evolution of the wave function is what guides the evolution of particles. And there's not really, well, I guess my main question is, for a lot of Bohmians, this is the way they think about the world, that sort of we have to model things as particles, and therefore we have to find out how particles evolve. And I was just wondering how you think about the world around you in sort of the paradigm of many worlds in the multiverse. Do you think along the lines of Wallace and sort of Daniel Dennett's functionalist interpretation? And sort of what you have to say to this sort of Bohmian interpretation that you have these two conflicting frameworks of, or not conflicting, two related frameworks of.
Right. Well, I'm not quite sure what you mean by two conflicting frameworks, because
yeah, they're linked.
I thought Bohmians think that they are compatible, in fact, necessarily complementary or whatever. But anyway, the thing you have to ask yourself if you are a Bohmian is the pilot wave real? Is it a real feature of the universe, or is it not? Is only the representative particle, or whatever you call it, is only that real? If the representative particle is the only real thing, which I think is the psychological motivation behind Bohmian mechanics, then you have to concede that it is driven along by something that isn't real. It's driven along by pure mathematics or something. Whereas if you concede that therefore the wave function must be real, the pilot wave or whatever you call it, then you must concede that the pilot wave contains people-shaped, unoccupied grooves where the particle is not, but where people are having conversations, people in the unoccupied grooves. Some of them believe Bohmian mechanics, some of them think it's rubbish. You know, the full panoply of things that happen in the world represented by the particle also happen in all the other grooves. And denying that they exist is logically the same as denying that the dinosaurs existed, or denying that Australia exists, or denying that anyone beyond your computer screen exists. Now, in contrast, I don't think there's much of a question to answer in the case of Everettian quantum mechanics, because at least in decoherent Everettian quantum mechanics, the ontology of the world is the same as it was classically. If we think of coherent observers and that kind of thing, then that breaks down, and we may need a new conceptual framework and new language and so on. But for everyday life, there's nothing new to understand. Just today, I tweeted a lecture given by Harvey Brown, which who I think has said the last word on this issue, in my view, where he describes some of the philosophical knots one has to pull oneself through if one is to defend the Bohmian interpretation. As for functionalism and physicalism, I think that's an unrelated issue. Those are issues of the metaphysics of thinking and of what a person is and so on, which are questions orthogonal to, well, they're orthogonal to quantum theory, to Everettian quantum theory. Now, of course, if you make up a theory in which the mind has a special place, then the two issues collide. But in Everettian quantum theory, they precisely don't.
I think we have a follow-up question from Jamal.
Hello, thank you for the opportunity of being in this question and answer session. My question refers to the book, The Science Can and Cannot, that one of your grad students created. When I was reading that book, when I was reading that book, I came across how you were trying to use some instances of set theory and information theory to try to give more breadth to constructor theory. And my question regards, would the halting problem in Gödel's incompleteness theorem also be some of the things that would also be added to constructor theory when you add set theory?
No, they wouldn't, or at least we don't expect them to be added, because those issues only arise for infinite sets. And constructor theory regards, although the universe may be infinite, it regards physical systems as always finite. It only makes statements about finite systems. So they can be arbitrarily large, but still finite. So therefore, constructor theory does not make statements about the universe as a whole. The universe is not what we call a substrate. It's not something that a constructor can act on. So you can think of the universe as being an emergent property of many finite objects. But you can't think of it as a first-class object within constructor theory. By the way, I should say that constructor theory is a work in progress. I don't think, I mean, some people disagree with me, but I don't think it would be the right thing to do to first make a rigorous formalism for constructor theory and then work out what it means. Of course, it might be that that's the way one has to go, but I don't think that's a good idea if one can possibly avoid it. We need to work out what it means first, and then think of a mathematical framework that suitably expresses what it means. I mean, we have a mathematical framework that's good enough to be going on with.
I guess, yeah, we will be talking about like creation of theories. So maybe we should ask you one final question on quantum physics. And as I said before, they're all interlinked, so we can come back to it. But maybe let's talk about time a bit. in the fabric of reality, you state that the flow of time is not real. It's an illusion. So why can't
no, it's not an illusion. It's not real, and it's not an illusion. It's a mistake.
It's a mistake? Okay.
Yes.
But then why can't we access past snapshots of the universe, whereas it feels like we are flowing towards the future snapshots?
Right. What we can access is a question of which physical processes are available under the laws of physics and which aren't. There are plenty of physical processes like obtaining a sample of the center of the sun, or seeing the center of the sun, or seeing a neutrino, or whatever, which the laws of physics happen to not provide the right kind of interactions for us to be able to harness those interactions to perceive those processes. And the same is true of most of the past, and the same is true of most of the future, though interestingly, different subsets of the past and the future that we can know anything about. And I think that's a very, there are very powerful insights to be gained there. But so we shouldn't be surprised when there's something we don't know. We shouldn't be surprised when there's something that the laws of physics forbid us from experiencing. What we should be surprised is if there's something that the laws of physics forbid us from understanding. I think that would be a very supernatural kind of world to live in, and I don't think we live in it.
I see. Okay. I guess to tie the multiverse to evolution, we have a question. Is fine-tuning necessary for intelligence? To explain, we found ourselves in these laws of physics because we could only exist in these laws of physics. Would there be a way for the laws to be different, but intelligence to exist? And by intelligence, we mean someone or something who understands the laws that govern it. Should we call that life? Or are laws necessary for your description of life?
Oh, that last question seems to be at odds with all the rest of the questions. Are laws necessary? Well, laws, I can only understand the term laws in the context of understanding something. We understand something via laws, and in that, if that's what you mean by laws, then yes, they are necessary. But I think you may have meant, are particular laws necessary, like via the Anthropic principle? Yeah. I think the Anthropic principle is kind of obviously true, but what it tells us, I think, is very, very limited. I actually discussed this quite a bit in my other book, The Beginning of Infinity, where I give an argument due to Dennis Sharma that shows that if there are many different kinds of laws instantiated in reality, and the only reason we see the ones that we do are that the only reason is that there's no one in the other ones there to ask the question, then the most likely thing is that we are only just in such a universe. I think this argument was also made in a slightly different way by Richard Feynman, but I heard what I think is a devastatingly convincing form from Dennis Sharma. And so if the universe is only just fine-tuned, which by this argument it must be, then we should expect at any nanosecond to be wiped out, because we would be surrounded by hot stuff that will kill us in the next nanosecond. And so what I've just said proves that isn't so in a certain sense. We're still alive.
Do we have any follow-up on that? Yes, we do. Andrew Salto. Sorry, you're muted.
Can you hear me now? I put the question in the what is wrong with probability as a measure of the number of worlds in which one is defined?
Oh, well, this is an old truism in probability theory. Probabilities are only equal to frequencies if the things in question are equally likely. So probability is frequency over things that are equally likely. What does equally likely mean? It means they have the same probability. What does probability mean? And so on. So that would lead to an infinite regress or to circularity or whatever. And it's worse than that in the case of like multiverse type reasoning, because you can easily make a model of a multiverse that doesn't obey quantum mechanics, where the frequencies are obviously not probabilities. So somewhere I wrote an example of this where you have there are a lot of copies of you all in identical prison cells, and you are also identical. You know, this is a non-quantum thought experiment, and then half of you do one thing and half of you do another, and then the second group, half of them does one thing and half of them does another, and then by probability the first group would have probability half, the second group have probability 1/4, third group have probability 1/4. But you can achieve the same physical effect by dividing into 3, in which case they should all have probability 1/3. So that's a world in which probability doesn't make sense. The fact that probability doesn't make sense in our world is, in my view, an amazing property of quantum theory. We had to work hard to prove that property. And if you change quantum theory just slightly, it no longer has that property.
Thank you very much.
Thanks, David. I guess we can still talk about evolution to change the topics a bit. A meme, as described in your book, is a theory or joke that survives through iterations, if I'm not mistaken.
Well, it's any idea that can be replicated, yes.
I guess it's a container for knowledge.
Yes, yes. So if it can be replicated to more than random degree, then it must contain, it can be said to contain knowledge.
Now memes are an widespread internet phenomenon.
By the way, what I just said is, and what you said is true of genes as well. It's true of any replicator.
You guessed the question. The question was how are memes are related to genes?
So memes and genes are both replicators. So in that sense, the theory of replicators applies to both of them. And there are illuminating properties of both that both share, where each of them can tell us something about the other. But memes and genes have a radically different replication mechanism. Again, this is in my second book, The Beginning of Infinity, which you should all buy. The genes, when they replicate, they are copied blindly. So the only bottleneck to their exponential growth until they cover the entire universe, the only bottleneck is their actual effect on their holders, whether they increase or decrease the chance that that holder will survive will survive in time to replicate the meme, the gene, sorry. But a meme has got two bottlenecks. First, it must pass the test of being understood and replicated into the mind of a new holder. And then when the holder then executes it, it must do something, which like the gene. So that second bottleneck is the equivalent of the gene. The first bottleneck has no analog in genes. And that makes the natural history of memes radically different from that of genes. It means there are these two kinds of memes, that they have different replication strategies. Neither of them has the same replication strategy as a gene. There is no way for a meme to replicate itself by blind copying. Humans are incapable of blind copying anyway, but even if you try to engrave your meme on a stone obelisk, that obelisk will wear away unless somebody tends to it. And that is not true of genes. They can survive for billions of years, and because they are maintained by a blind error correction process. Whereas human memes have to be maintained by humans actually going out of their way to maintain them in every generation. That's another difference. Genes need not be enacted in every generation. If you don't, there's the example I give, if you don't break your arm, you will still pass the genes for repairing broken arms onto your children. But if you don't enact your religion, then your children will never hear of it.
See, so that first bottleneck is the difference between a live replication and non-living replication, whereas a meme or your book is a container for knowledge. It replicates as a printing house copied it, and I acquired some knowledge through it. But if without me, it would not be able to replicate. The knowledge would go away, or without the readers. And
yes, without the just printing it is blind replication. But really, that's not. If we look at generations, then if humans don't read the book, then almost all printed material will never be read again, nor enacted.
We have a question from Arjun.
Yes, it's a pleasure to be asking a question. So since we're on the concept of memes, I think what you write in the beginning of Infinity, which I have right here, is in chapter 15. It's like extremely profound what you come by with the idea of memes and the effect and implications on society. And you write a little about Inexplicit, the inexplicit component of memes and ideas, which I thought was very interesting. But could you expand on that a little, since you write, in fact, all ideas have some inexplicit content, since even a knowledge of the meanings of the world, of words, is held largely inexplicitly in our minds. But just to sort of unpack that a little, maybe I'd love to hear your take on that.
Yeah, so first of all, the way that it couldn't be is that all knowledge is explicit. That couldn't happen, because if all knowledge were explicit, then the meaning of words, let's say I use a word like castle, and somebody doesn't know what a castle is, they would have to look in a dictionary. And then in that dictionary, a castle will be defined as a type of building which has the following properties, etc. But in order to, if the person doesn't know what building is or what a type is, then they have to look up type. And it's obvious by a counting argument that a dictionary cannot possibly define, even in that straightforward sense, cannot possibly define every word in it, because there would have to be a root to every definition, and that root would itself be undefined. So how is it that inexplicit knowledge gets around that? Well, inexplicit knowledge doesn't have definitions. And in fact, as Karl Popper says, definitions are highly overrated. They're nearly always useless. We have knowledge encoded in language, but not as definitions. They're encoded as ideas expressed in language. And the way children learn language is by guessing what words and grammatical structures mean. And they when they guess wrong, they correct their guess. And when they guess right, they use the word and then perhaps correct it again. No two people end up with the same meanings of all the words. Loosely speaking, we say that everybody who speaks English can understand each other, but that is not true. As soon as you get into any kind of detailed discussion of anything, you find that people have a different idea of what it means, like to exist, or what it means to be true, or just basic things like that. People have radically different intuitive ideas about, which if they are naive, they think that everyone else has them too and are just being obtuse. So I don't know if that answers your question. I mean, I've said like what can't happen and what does happen, but.
Yes, it does help.
Okay.
We have another question. Also, how are we doing on time, David? Do you think we could go on a bit more?
Yeah, up to you.
Okay, maybe like 30 more minutes, I guess, then.
Sure.
Finish up, maybe less. We have a question from Babak.
Hi, thanks. Hi again. So we have physical theories of what we understand now as physical theories of information, starting with thermodynamics and second law of thermodynamics, especially. But it seems to me that we are missing something there as a physical theory of knowledge and how that might have a bearing on all of this. Do you have any thoughts on that to share?
Yeah, well, first of all, we already do have some quite deep knowledge about knowledge, namely epistemology, of which the best that I know of is Karl Popper's epistemology. It obviously is insufficient, since if it could tell us everything about knowledge and how it works, and so we would be able to use it to make an AGI. And I take it as axiomatic, if you like, that until we can make an AGI, there is a huge gap in our understanding of knowledge. Now, as a separate matter, I am kind of hoping that constructor theory will tell us something about knowledge, since knowledge is an abstract constructor. And that can't be an irrelevant fact. So I think there will be a constructor theory of knowledge eventually, which may or may not improve on Popper's theory of knowledge. But even if it does improve on it, I'm afraid I still think it won't be the full answer. Well, when I say the full answer, I mean, it won't solve the problems that we have now. I mean, nothing is ever a full answer in the sense of solving all future problems. But I think that the various issues about knowledge, like the question of identity and the question of qualia and so on, knowledge, consciousness, free will, and so on, those, we have partial knowledge of those, especially knowledge of what is a bad theory about them. But we don't have an actual explanatory theory of them. And so we don't know that. It's a whole other vast area that we don't know about. At least I think it's a vast area. Maybe somebody will come up with a single equation that just solves it.
Wouldn't that be nice?
Yeah.
Cool. We have a question from Charles.
Yes, hi, David.
Oh, hi, Charles.
Yeah, my question is about the time and the multiverse. So I guess I'm going back a bit. I wonder how can the multiversal picture of time accommodate the idea of an open future? If, like in classical space-time, determinism ends up fixing the multiverse. And by open here, I refer either to people's choice or to knowledge creation, I guess.
So the open universe is not intended to be open in the sense that there's indeterminism. In fact, indeterminism does not help in any way to make the universe open in the sense we want it to be open. In fact, if anything, it makes it worse. It makes the problem worse. We have to, the problems though arise at a different level from the level of microscopic physics. They arise at the level of understanding knowledge. Again, when I say that I have freely chosen to do something, I mean that I have created in the process of deciding it, and I don't mean simply a choice like whether I should have strawberry or butterscotch ice cream, where it doesn't really matter much to me. I'm talking about decisions where I had to think about it and where I am a different person, as it were, after having thought of it. In those cases, I have created something new. I have brought something new into the world, namely the knowledge that I then use to guide my choice. So the universe can be open to that or not. That's the sense in which Popper used the word open, in the sense of the open society and its enemies. No society is totally closed. No society that we know of is totally open, but still there is a vast and important difference between societies that are basically open, or which at least strive to be, and societies which are basically closed, or at least strive to be. And that's the sense in which it is important for a society to be open. And I think exactly the same is true within one person. That's what we mean by being open to ideas, or it's what we mean by having had a new idea. You know, I could say I had a new idea yesterday about so-and-so, and somebody, you know, a rabid determinist would say, no, that idea was already there at the Big Bang.
Yeah.
But in a sense it was, and in a sense it clearly wasn't.
So we have to basically, in order to think of openness, we have to kind of put back in the drawer all the framework of laws of motion, initial state, determinism. Otherwise, it might be just meaningless and we're just gonna loop around.
Yes, because we shouldn't be surprised that the answer to the problem is at the same level as the problem. The problem isn't about electrons.
Exactly. Yeah.
If you have you know, if you're worried about how your theory of knowledge is compatible with your theory of electrons, then that's kind of, I don't know what you call it, a category error or something. It's like saying, well, one of the examples I give in the beginning of Infinity is like, if somebody says, if you're watching a conjuring trick in the theater and the conjurer does something that looks impossible, and you say to your friend, how the hell did he do that? And the friend says, laws of physics. He hasn't answered your question. And if he says, oh, the conjurer did it, still hasn't answered your question. Your problem was at a different level from those two levels. It's at one level up. The answer is something like, when it looked as though he was putting the ball in the second cup, he wasn't, and he then put it in the third cup. That's the beginning of a real answer.
Mm-hmm.
And it's compatible with the first two answers, but the first two answers don't answer the question.
Thank you. Yeah, I see.
Okay, thanks for the question, Charles. We have two more questions. So I guess we move to the strand of epistemology now. But let's see where these questions come from. Toby? Hi, Toby, you have a raised...
Hello.
Yeah.
Hello. Can you hear me?
Yes.
Yes. Hello there, David. I have a question about decision theory and the arrow of time. And this could be a bad conjecture, but I want to know whether observation of time asymmetric increase of entropy could feasibly be a result of agents maximizing their rational expectation values in a time symmetric world, much the way you derive probabilistic Born rule from non-probabilistic many worlds. So that agents such as ourselves are playing like a game as if we can make sense of the world in terms of causation, change, and predicting the future, but where those things have no intrinsic, or where that time symmetry has no intrinsic existence of its own. So I was wondering if there's been any work in this area, or whether it's a bad avenue to think about.
There have been people who have tried to link what's it called, the entropic arrow of time with the knowledge arrow of time. I'm not very persuaded by that. I think there's a lot more to knowledge in general and to the knowledge arrow of time in particular than just physics.
Yeah.
As I said before. Constructor theory may provide a closer link, but it hasn't yet.
Yeah, I was. The sort of conjecture that I had was, I think one of my criticisms of it was that it would mean, if it was true, causation would be it would mount to some. I think it would mount to some form of subjectivity, because I can imagine random agents, say in the multiverse, which they're determined by laws of physics and stuff like that, but their actual arrangement in time would be a fiction or a story that would be correlated between sets of agents. But that would mean that the kind of causal structure that I tend to think would be objective would have to be subjective. So I thought that was probably one major problem with the idea.
I'm not sure I understand quite what the idea you're putting forward is, but it kept sounding to me that you were mixing levels of explanation again. The question of what can communicate with what is a question of physics. It has an answer in terms of laws of physics, and no higher level explanation can add anything to that.
Yeah, right.
If on the other hand, you're talking about like what things mean, like when you realize that Napoleon isn't what you thought he was, then at the level of physics, that doesn't change Napoleon, but it may change how Napoleon affects the future from now on.
Yeah, I thank you. That's I'll think about separating levels of explanation a bit harder. Yeah. Thank you.
Yeah, we had a few more questions pop up. Owen?
Hi, yeah, thank you. So earlier when we were talking about memes and genes, you called them containers of knowledge. And I thought that sounded a bit strange to me because I would consider them more containers of information rather than knowledge. Maybe I'm just mistaken there, but
no, that's a very important distinction. Information, so knowledge is a species of information, but very little information is knowledge, because the vast majority of the information that exists in the universe does not have causal power. It doesn't have the power to replicate itself, that is basically, but it also doesn't have the power to systematically cause transformations in other systems. So, you know, you could take a census of all the grains of sand on all the coastlines in the world, and that would be a vast amount of information. And almost none of that information is involved in the explanation of anything else. So, whereas a much higher proportion of, let's say, the information in the books in the Bodleian Library, still, you know, not 100%, probably not 10%, but vastly more than in the grains of sand, have the power to cause things to happen. Historians can go in there convinced of one thing, come out convinced of another thing, and then go and do things in the world that have much greater mass and momentum and generally causal effect than the grains of sand.
Yeah, okay, I see. Okay, yeah, and also earlier you were saying time is a mistake, and I'm not sure I understood exactly what you mean by that. If you could
Well,
just clear that up.
when we think that time flows like a river, or you know, whatever metaphors people say, that's obviously not true. You know, the time at this moment today is not going to flow anywhere. It's not going to flow to tomorrow. It's not going to flow to the day after. Today will always stay at whatever today's date is. And that doesn't change. And nothing about the sequence of time changes at all. Again, causation happens from one time to another, but the time itself doesn't do that. It's physical objects that do that.
Okay, but we still need time as sort of a substrate to understand what causation even means. Like, we still need the concept.
Well, we need the concept of causation, but I don't think we need the concept that time flows. I think,
okay, yeah, I see.
Yeah.
Thank you.
Thanks. Sam Kuipers.
Yes, hi. I had, I'm not sure it's a very serious question, but you said earlier that memes replicate by using basically two methods. And one of them is that you need to enact the meme during someone's lifetime for them to remember it, and then they can pass it on. What if an AGI were born with like pre-programmed knowledge of, say, the Bible or something, or of certain religious traditions, so that you could bypass that? Would that in any way change meme evolution?
I don't think it would. By the way, I'm not sure which. So memes have two bottlenecks to pass through, unlike beans. There's also, in meme replication, there are two different kinds. So I think you meant the first of those things.
Yeah, I think you said, if you don't enact, you know, your religion to your child, then they won't know about it. But you, if you never break your leg, then they will still.
So if you, the best you can do, I think, is to engrave something deeply on a diamond. But then you've got to put the diamond somewhere where you can ensure that somebody won't grind it up and use it for industrial purposes, or eventually so that it won't burn or evaporate or something like that. If you put it in a robot, like you said, and the robot, let's say, is immortal, then that won't work, because the robot, let's say you put the Bible or whatever, the robot will have a different interpretation of the Bible next year from what it had this year. it's presumed, I assume by hypothesis that it's a thinking being. Its opinion of what things mean will change. That's what humans do. That's what any person does. If it's not a person, if it's just like the diamond, then it will eventually be ground up, so on. You know, it will only be preserved if it's useful for something, or if somebody has a theory that it ought to be preserved. And in either case, that's a property of the information that it has in it, which makes that information into knowledge. But if it's just information, or if it's useless information, I mean, then it will eventually fade away. I suppose there's an exponentially small chance for any particular piece of information, of useless information, that it will eventually survive. I mean, no doubt somewhere on one of those beaches around the world, there's a configuration of sand that will still be exactly the same after the tide has come in and gone out again.
Thanks for the answer.
Thanks for the question, Sam. I guess let's take one final question from Ante and then bring the conversation more to how to describe our more comprehensible, immediately accessible world. Ante, yeah, go ahead.
Thanks. My question is, in constructor theory, the universal constructor, is there a meaningful distinction between, let's say, something like DNA that can make a person and then it's automatically a universal constructor? Or does the effect have to be in some way more immediate?
So I have to apologize to everybody that in my book, The Beginning of Infinity, I talk in a very loose way about the universal constructor, which turns out to be not very suited to constructor theory. In particular, I spoke of a human as being a universal constructor, and that's not quite right in an important way, namely that a universal constructor, like a universal computer, has to be programmable. So it's universal in the sense that for everything that can be constructed, there exists a program that will make the universal constructor constructed, which means that it has to be perfectly obedient. Like all constructors, it's an idealization, but to say that something's a good approximation to a universal constructor, you mean that it's very, very, very obedient. But humans, neither humans individually, nor human society as a whole, is at all obedient. So now you might say, well, it's not the human that's a universal constructor, it's just the human body. And forget about the brain, you know, you have to program. The brain instructs the rest of the body, but then the rest of the body has a finite lifetime. And anyway, most constructions involve cooperation between different people, and it involves machinery. And one day when we have universal constructor robot type things, it will involve those. And then it doesn't really make sense to consider the human body as a universal constructor when all it is a front end for the real universal constructor, which will be a type of robot. Okay, so having made that apology, I've forgotten what your actual question was.
Well, if DNA can build a human, then is it automatically a universal constructor?
Yes, well, so since a human isn't a universal constructor, the answer is no. So if there were a way for DNA to not only build a human, but to install in the human brain a program for doing an arbitrary thing and for passing that on to its offspring, so that they would work for generations and generations to build rockets to go to the moons of Mars and convert them into busts of Napoleon. Unless there's a way for DNA to do that, then the answer is no. I don't think there can be a way of doing that, but that's another issue. I mean, that's not a fundamental issue. It could be that DNA can do this without going via the intermediary of a human. The DNA could build an animal robot that builds other robots, and so on. And then the DNA installed in a certain cell, because something has to make the DNA work, like with the ribosomes and so on. It could be that the DNA can indeed make anything when installed in a suitable cell. Again, I don't think so, but it's not impossible from fundamental principles.
Okay, thanks.
Thanks for the question. I guess we can bring the conversation towards more practical questions. If I may say, like more accessible in our everyday world with our hands, which, like, as quantum computers right now we have that are being built that we can touch and play with. What is your opinion on current progress on quantum technologies and the industry in general?
Unfortunately, I haven't got my finger on the pulse of current technology. My view of current technology is just that of a layman who sees things on Twitter from time to time. So I'm naturally skeptical about claims to have achieved universality, and I'm naturally gullible about claims to have universality in the sense of universal quantum computer. And I'm naturally gullible when it comes to claims about having achieved something amazing, like a new functionality. Just like in the case of AI and AGI, I'm skeptical about claims to have made progress towards AGI, and I'm fully expecting amazing, brilliant progress in AI, like every day.
Okay, but was there maybe a technological development that you were positively surprised to see in the last few years, or what are some scientific trends that you were excited about? You are excited about right now?
Well, that's a much wider question. Or do you mean in regard to quantum technology?
Yes.
Again, I'm afraid I don't know.
Maybe generally, actually, maybe not immediately related, but related. Maybe.
So I think the big picture is that I think that progress in fundamental progress in physics has slowed down during the last few decades, and it has slowed down not because we've reached all the low-hanging fruit or for any reason like that. There's a sociological reason that has stultified the scientific world in regard to almost all fundamental issues. So most things haven't made progress. There has been a lot of progress in cosmology, which again, I don't know much about. I think that the inflationary model seems like a fairy story to me. And if it turns out to be true, it will be amazing. And I mean, when I say it turns out to be true, I mean, if the underlying mechanisms are found to have some basis in new theories of elementary particles and that kind of thing, then that will be amazing. If it turns out to be false and is superseded, that will also turn out to be amazing. So that's a nice state for a field of science to be in, that whether it succeeds or fails in its current hopes will either way, it'll be amazing. Computer technology, aside from quantum, is of course making huge progress, and computer software in the sense of machine learning and AI is also making rapid progress. I've probably forgotten the most, I'm not remembering the most important thing, and somebody will come to me afterwards and say, hey, you know, you dissed our field, but I don't mean to diss any field, but
you've been talking about virtual reality a lot as a theoretical construct to explain the fabric of reality in the book.
Yeah, well, that technology is improving, but it hasn't improved in any fundamental way for many years. It's just the resolution has got better. You know, the programming has got better, but there's nothing that would amaze anybody from the 1980s, let's say. They'd be amazed at the actual technology, and like they'd say, you know, shut up and let me try this out, rather than answer your questions. But there's nothing fundamentally new that they didn't think of. Whereas, for example, if you go a bit further back and look at what was considered to be the most amazing possible future in the 1960s, let's say with Star Trek, there are a lot of things from that were actually achieved, and there are a lot of things from that were not achieved, and there are a lot of things that were achieved that were not thought of then, not even conceived of. That kind of thing has slowed down, and I think it's because of irrelevant, I mean, fundamentally irrelevant things like the sociology of science and the structure of scientific careers and the structure of universities and the public conception of the educational system altogether, you know, thinking of the educational system as a machine for passing on knowledge, is not very compatible with an open society. And open science is and should be the epitome of an open society, but it's less so than it has been in the past.
I guess we'll take one final question before we wrap up from Andrew.
Hey, David, I'm coming over here from the US. I am actually an analyst, and we invest in those cutting edge technologies at my VC firm. And so I'm curious to learn, well, with regard to trying to remove abstraction layers from what is cutting edge science and then commercializing that. And I think you've already talked on this a little bit, but what would be, I don't know, like an inflection point in the science community that could help proliferate like these more cutting edge frontier technologies, and because you said it's kind of slowed down, so what can kind of stop that stagnation? And
well, so one thing is to do with a combination of funding and organization. Scientific research ought to be organized in the form of where the fundamental unit is the research group. So if the research group could be one person, in which case that person should be free to do whatever that person wants to do. Or it could be a group, in which case that person, it should have a leader who decides who they want to work with. But the organizational structure should be flat, so that the leader is the one that talks to the funders. But apart from that, everyone, when they're actually in the lab or in front of the whiteboard, everybody's equal. So that's one thing. Another thing, this may sound like a very parochial issue, but I think they ought to leave graduate students alone. there's been a sort of mission creep in universities where it used to be like when I was a graduate student, it was taken for granted that you were an undergraduate, and then either you went in, if you wanted to do research, you would go into research, and you would start on day one being in some research group or working on some problem of your own or whatever it was, or you would first have to do an MSc and then start being a proper graduate student. But now, graduate students are, from the point of view of the research itself, they are not in a creative role. They're in a subordinate role. It's hard enough for people who come out of, say, a school with its regimented structure to do research, to build up on the on-ramp of an undergraduate degree, to actually do creative research. But this has been made harder and harder by more and more burdens being placed on graduate students. And then it doesn't stop with graduate students. Postdocs now have to spend a significant proportion of their time meeting irrelevant requirements from their departments, from the funders, from the government, whoever's in charge of them. So there's somebody who is called a postdoctoral researcher. That is, doctor means learned. They're a learned person. They've become a learned person. They're supposed to be doing research and creating new knowledge. Their job description says that they're supposed to create new and original knowledge, and yet they have to spend most of their time meeting existing criteria. That's not creativity. So those are a couple of things. No doubt there are many more.
Thank you.
So, as the final question, then, David, what would be your advice to those people? What would be your advice to future potential discoverers of algorithms or scientific theories? In other words, what would be your advice for seekers of the truth?
Well, I don't give advice because when you give advice, what happens next is then your fault. And I don't want anything to be my fault. So I think the only, I could say, just be aware that the hierarchy and the structure whose ostensible purpose is creating knowledge actually acts largely to prevent that. And the fact that this doesn't result in an immediate collapse of society is due to the fact that some people manage to find their way through the minefield, through the labyrinth, through the dark forest, and do the research anyway, despite all the discouragement and the compulsion to do irrelevant things. So, if my advice is find your way through the minefield, or find a field that doesn't have mines or something, it's not going to be much help.
Right. All right. Thank you, David. Applause. I don't know how we can do it on Zoom, but
well, it's been fun.
Yes.
Thank you all. Thank you all.
Thank you so much, David. Thanks for everyone who showed up. After maybe some edits, we'll post this on our website and our YouTube channel by Quantum Information Society. And I've seen that there were many questions in the chat. We had many questions that were unanswered. We couldn't take any questions from the chat. So we'll find a way to maybe somehow record those and make use of them in our future sessions. But thanks for everyone who showed up. I guess I'm gonna stop the recording now. Thanks, David.